for today's activity, we are going to be looking at the engineering process. So we're going to, we want to glue this paper into our journal. But if you notice, this paper is much larger than our journal. So we're going to have to carefully cut around this outer edge here, like so that it fits inside of our journal. We'll need to trim this arrow off. That is quite all right. It won't hurt anything. We know it's there. So let's trim up and over, down and back over. Be careful to leave all of these boxes intact because we need them. And now we're going to glue this into our journal. Now it won't glue like this, so we'll have to turn it sideways or sideways. Anytime we're gluing a page in our journal, and we can't glue it this way, but we have to turn it, we want to make sure the bottom of our page is facing the outside of our journal. So if I do it like this, the bottom of the page is facing the inside of the journal. No, no, no. The bottom of the page must face the outside of the journal like so. So once you are confident you have it in the right location, we can get our handy dandy glue stick and glue this down. Feel free to pause the video if you need to and play it when you are caught up. Now this one is a little bit of an exception because this page is so big. To glue it in, you'll notice we covered up our page number. That is quite all right. Just remember it's page 7 for our table of contents. So once this is in, let's go back to our table of contents, speaking of, and let's add this to our table of contents. So back to table of contents. We want to make sure we're writing on the next empty line. This activity is called the engineering process. Add my dots. And you remember what page it was on? Page 7. All right, so every engineer goes through this process, and this is a cycle. What does it mean for something to be a cycle? It means it goes all the way around, and then it cycles again and again and again, right? A cycle is a repeating process. So this is the engineering process, and it operates as a cycle. Up here in the top left is our first step, brainstorm. This is where you come up with problems. This is where you think about what is the problem, what are the constraints, and you come up with ideas that might solve that problem within those constraints. Remember, constraints are limits. For the brainstorm, you want to write down any idea that you or your group can think of, right? Anything works. Some ideas might be great. Some ideas might not be great. It doesn't matter. In a brainstorm, you jot down everything you can think of, right? So maybe we come up with plan A and a plan B and maybe a plan C. Now, once we have enough information in the brainstorm, we can move to design. Design is step 2. When we design, we draw and label your solutions. So in a design, we take one of our brainstorm ideas. Let's say our group decides on option B is a good idea. So in option B, we want to come over here and we want to sketch out what we think option B will look like. So if we're talking about Save Fred, right? Save Fred is a engineering challenge where Fred, a gummy worm, is stuck on top of his sinking boat. Now, Fred is a gummy worm, and Fred cannot touch salt water. So the group members have been flown in to save Fred. But the condition is the group members can only use the 4 metal paper clips to touch anything at all. So Fred will need to be saved using these 4 paper clips. What's important in the design stage is that we are sketching out what our plan is. So in the Save Fred plan, right, what is our problem? Well, Fred needs to be saved. What are our constraints? Well, constraints are we can only touch our tools. And the tools are, in fact, paper clips. So we identified the problem, we identified the constraints, and now what are possible solutions? Maybe we can use the tools to move the life preserver around Fred's waist. So we identified our problem. Fred needs to be saved. We identified the constraints. We can only touch our tools, paper clips, meaning if you are a group member and you're working on this, you cannot touch Fred or the boat or the lifesaver. This is the only thing you can touch. So the solution is we're going to have to use the tools to move the life preserver around Fred. So we come up with this idea. Seems pretty good. Let's come over here to design it and sketch it. So what we're looking at here is our tools, Fred, and our life preserver. But if I wasn't looking at, if I didn't know what this setup was, let's say I was just a principal or a different teacher or another student that walked in and looked at this drawing, I wouldn't know what the heck I was looking at. In science and in this notebook, every single illustration, drawing, sketch, design, every one that you make must have labels. So I need to make sure that I am labeling what everything is in this problem. In this, I'm sorry, not this problem, but in this design, in this sketch. So these are our tools. This is Fred. This is our life preserver. All right. Once I have designed our plan, sketched it out, and labeled it, we can go down to step 3. Step 3 is where you build and analyze. We are using the word build, but really there's not much building in this one. But step 3 is where you try your idea. So here we thought about the idea. Here we drew a plan for the idea. Here is where we do that plan. So there's not much to draw here, since if you're doing the Save Fred, this part will kind of be done in real life, trying to save Fred. But what goes in the box is the analyze. When we analyze something, we want to talk about what worked in our design and what didn't work. So what worked? The tools were able to move Fred. Now you might have some other answer here because this is going to be specific to your group and what y'all's plan was if you're doing the save Fred. So what worked? The tools were able to move Fred. And the life preserver. I'll put a check to say that worked. But what's really important about analyzing is you need to identify what didn't work. Right? So I want to put an X for what didn't work. Or put an X for why this first plan did not work. Because I promise you, the very first time you try your plan, whatever it is, the first time you try it, you're probably not going to get it. And it's important to understand why. So in Analyze, we think about what part of this plan went really well, but we also need to look at and analyze what part of this plan did not go well. So let's say if we have 4 group members, maybe one group member was in the bathroom when we tried to do our plan. So something that kept us from being able to succeed on this first attempt was maybe we only had 3 group members. Okay? Usually some other things don't work. Maybe the life preserver was not big enough to fit around Fred. Right? Maybe this ring in the middle wasn't quite big enough to fit around Fred. So let's add that. Another thing that didn't work is life preserver was too small to fit on Fred. All right, so this is a good analyze because we have 1 or 2 things that worked. We have 1 or 2 things that didn't work. Now moving to our 4th step. In the 4th step, you want to modify. We want to make changes to our design to be successful. So come back and look at Analyze. Take what did work. If this idea did work, let's keep it. That's awesome. Let's use that on the next try. But when we modify, we need to look at what didn't work. And modify means to change. So we need to look at what didn't work and we need to make changes. We need to modify that part of the plan. So if in this plan, what didn't work was we only had 3 group members, right? Because one was in the bathroom or maybe taking a nap or maybe goofing around. So what do we want to change? What do we modify about this part? Well, we want all 4 group members. So what are we modifying? We are going to use all 4 group members. All right, so that's a good modification for this first piece. Now for this one, what can we modify for this? So this problem was the life preserver was too small to fit on Fred. These life preservers are gummy material, so they can stretch. So what if to modify this part of our design, what if we use tools to stretch out life preserver so it's larger? All right, so now we have modified the 2 things we have a plan to modify the 2 issues that we had when we first tried our attempt. So now that we have 2 modifications, now we go back to the beginning, right? So let's brainstorm. How can we use all 4 group members? Right, so that's another brainstorm talk. How can we use the tools to stretch out the life preserver so it's large enough to fit around Fred? That's another brainstorm idea. So now that we talk about a couple ideas on how we can address these modifications, we're in brainstorm, we talk about how we can implement or use these two modifications. How can we try them out? Let's think of some ideas on how we can use all 4 group members, and let's think some ideas on how we can use the tools to stretch out the life preserver. Then we go back to step 2 again. So we're going to sketch out how we're using these life preservers, right? So maybe we're taking the paper clips and we're hooking the life preserver to stretch it out so that Fred will be able to go through the center hole in the life preserver. And remember, anytime we're drawing a design in this notebook or in science, we add labels. Tool. So I labeled my life preserver, I labeled my tools, and I labeled Fred. Now, once we have our design, our new design going down, then what do? Then we move back to step 3, which is build and analyze. So let's try our new idea, and then let's analyze it. Think about what worked and what didn't. Once you figure out what worked and what didn't, we go back to modify. We adjust what didn't work. We make modifications. Then we go back to brainstorm, back to the drawing board, and we try it again. Engineers do this multiple times until they reach success.